What if there was a shortcut through reality? A secret passage so powerful, so dangerous it was forbidden. Not by any human law, but by the very rules of the universe. We've all seen stories of journeys to other universes, but cutting-edge physics has a secret of its own, and it's called string theory. It paints a picture where our universe is just a fragile membrane, floating in a higher dimension. And a wormhole could be the ultimate forbidden door, a terrifying tunnel connecting our world to a completely alien one. What would we find on the other side? And more importantly, what might find its way through to us? To even begin to understand this forbidden shortcut, we have to start where all modern theories of gravity do, with Albert Einstein. 100 years ago, Einstein's theory of general relativity blew our understanding of the universe wide open. He showed us that space and time aren't just a static, empty backdrop for events. Instead, they're woven together into one dynamic thing, space-time. And this space-time fabric isn't flat. It gets warped, bent, and curved by anything with mass and energy. That curvature is what we feel as gravity. The Earth orbits the Sun not because of some mysterious force pulling on it, but because it's simply following the straightest possible path through the curved space-time created by the Sun's incredible mass. But it was deep inside the beautiful, complex math of his own theory that Einstein, along with his colleague Nathan Rosen, found something truly bizarre. Their equations allowed for the existence of bridges, theoretical tunnels straight through the fabric of space-time. We know them today as Einstein-Rosen bridges, or more famously, wormholes. In principle, a wormhole is a shortcut. Imagine space-time is a big sheet of paper. To get from one spot to another, you have to travel across the surface. But what if you could just fold the paper over, bringing those 2 points right next to each other, and then poke a hole through them? That hole, that tunnel, would be a wormhole. It's a passage connecting 2 distant places in space, or maybe even 2 different points in time. The idea was stunning. It suggested the universe might have hidden pathways, secret corridors that could let us bypass the cosmic speed limit, the speed of light, and make the unimaginable distances between stars feel trivial. It was the ultimate cosmic cheat code, buried right in the rules of reality itself. The discovery of Einstein-Rosen bridges kicked off a century of wild speculation. Could we build them? Could we find them? Could we finally break out of our solar system and explore the stars? But all that excitement quickly slammed into a series of brutal, physical dead ends. The first huge problem is that these classic wormholes are catastrophically unstable. In 1962, physicists John Wheeler and Robert Fuller proved that the original Einstein-Rosen bridge is a one-way, one-time-only deal that collapses the instant it forms. It pinches off so fast that not even a single photon of light, the fastest thing in the universe, could make it through before the exit slams shut. Trying to send a person through would be like trying to run through a doorway that shuts 1 billion times faster than you can blink. The gravitational forces inside are also insane. Any object trying to cross through would be ripped apart by tidal forces we can't even imagine, shredded into a stream of fundamental particles. It's not a journey, it's an execution. But let's say you could survive that. The wormhole itself still needs to be propped open. The very nature of gravity means the throat of the wormhole wants to collapse under its own weight, just like a tunnel dug in sand. To keep it open, you'd need something with properties that sound like pure science fiction. You'd need exotic matter. This isn't just something that's hard to find. It's matter with truly bizarre properties. Most importantly, negative energy density. All the matter and energy we know, from stars and planets to you and me, has positive energy. It pulls things together with gravity. Exotic matter would have to do the opposite. It would need to be gravitationally repulsive, pushing space-time apart to fight the crushing collapse of the wormhole's throat. And while certain quantum effects show that tiny amounts of negative energy can exist for fractions of a second, no one has ever seen or has any idea how to create exotic matter in the huge quantities needed to stabilize a wormhole big enough for a person to travel through. So for decades, the wormhole remained a tantalizing but frustrating dead end. A beautiful idea on paper that seemed impossible in reality. The case of the cosmic shortcut had gone cold. Just when it seemed like the case was closed, a revolutionary new idea entered the investigation, coming from the very strange world of string theory. String theory is one of the biggest attempts at a theory of everything. It suggests that at the most fundamental level, everything in the universe isn't made of particles, but of unimaginably tiny, one-dimensional vibrating strings of energy. How these strings vibrate determines what kind of particle we see: an electron, a photon, or even the graviton, the particle that carries the force of gravity. And within this strange idea, a radical new picture of the universe emerged: brane cosmology. The word brain is short for membrane. This theory proposes that the three-dimensional universe we see around us isn't everything there is. Instead, our universe might be a three-dimensional brane, like a single gigantic sheet floating inside a much larger, higher dimensional space called the bulk, or hyperspace. Think of it like a single slice in a loaf of bread. Our entire universe, every star, every galaxy, exists on the surface of just that one slice. We can move left-right, forward-backward, and up-down, but we're stuck on our slice, our brain. But right next to ours, separated by a tiny distance in a dimension we can't see, there could be another slice of bread, another universe, another brain, floating parallel to our own. There could be countless brains, each a unique universe, maybe with its own slightly different laws of physics. This wild idea also offers a beautiful explanation for one of physics' biggest mysteries. Why is gravity so weak? According to brain theory, forces like electromagnetism are stuck to our brain. But gravity as a feature of space-time itself isn't. It can leak out into the higher dimensional bulk. This leakage would dilute its strength, making it seem much weaker than the other forces. This isn't just a cool story, it's a potential solution to a real problem in physics. And it completely changed the conversation about wormholes. Suddenly, we had a new lead. This is where our cosmic detective story has its breakthrough. This is where the two big clues, unstable wormholes and parallel brain universes, snap together to reveal a shocking new possibility. What if a wormhole isn't a tunnel through our own universe? What if it's not a shortcut from one side of our slice of bread to the other? What if, instead, a wormhole is a tunnel that connects our slice to a completely different one? In brain cosmology, a wormhole could be a true gateway, a tunnel through that higher dimensional bulk that links our universe to a totally separate one. The idea, still highly speculative, is that the immense gravity of two massive objects, like two black holes, one in our universe and one in another, could warp space-time so much that they actually pull their brains together. If the attraction is strong enough to overcome the natural tension of the brains, they could touch, merge, and potentially form a tunnel between them. This theory offers a fascinating, though unproven, possible solution to the stability problem. Some physicists speculate that you might not need that impossible, exotic matter to prop the wormhole open. Instead, the tension of the brains themselves could potentially act like the stabilizing force, like the structural support of a bridge. It's important to be clear, this is still very theoretical, and the stability of such a structure isn't guaranteed. But it reframes the wormhole from a fragile tunnel we have to build into a potential, natural consequence of two universes interacting in a higher dimension. Suddenly, the wormhole is no longer just a hypothetical way to travel faster than light. It becomes something far more profound and maybe far more dangerous, a forbidden door. A shortcut not just to another place, but to another reality. It's a plausible, mathematically supported idea for how travel between universes could happen. The dead-end case of the wormhole was suddenly wide open again, but the implications were more terrifying than anyone had ever imagined. Thinking about a tunnel to another universe forces us to face some pretty terrifying stakes. This isn't like traveling to another planet, which, while alien, would still follow the same basic laws of physics. A journey to another brain could mean stepping into a reality where the rules themselves are different. Maybe the basic constants of nature, like the strength of electricity or the mass of an electron, are just slightly off. A tiny change could mean that chemistry as we know it is impossible. Atoms might not be stable. Stars might not form. A universe like that would be instantly lethal to us. And then there's the journey itself. If a wormhole is born from the collision of two brains, that would be a cataclysmic event of unimaginable power. Traveling through that connection would mean navigating the most violent and chaotic region possible. But the most chilling thought isn't what we might find over there, it's what might find its way over here. Opening a forbidden door works both ways. If we can cross into another universe, what's to stop whatever or whoever is in that universe from crossing into ours? We would be creating a pathway between our reality and a complete unknown, with no way of knowing the consequences. It could be an invitation to forces we can't possibly comprehend, or it could just destabilize the very fabric of our own existence. The promise of the ultimate shortcut is undeniable, but it comes with the ultimate risk. This isn't just about exploration, it's about cosmic security. It's a door that, once opened, might never be closed again. The math whispers that the shortcut might exist, but maybe there's a very good reason it's called forbidden. The journey from Einstein's first glimpse of a bridge through spacetime to the mind-bending idea of colliding universes is a perfect example of human curiosity. It's a detective story played out on a cosmic scale, where every dead end has opened up a new, deeper mystery. For now, all of this remains on the chalkboard of theoretical physics. We don't have definitive proof that string theory is right, or that other brains exist, or that wormholes can really form between them. But these aren't just wild guesses. They are the logical, if extreme, results of our best attempts to understand what reality truly is. The universe is under no obligation to make sense to us, but as we keep trying, we uncover its deepest secrets. And maybe, just maybe, one of those secrets is a shortcut, a forbidden door waiting to be opened. The only question is, should we ever dare to turn the key? Thanks for joining us at the Celestial Theory on this journey today, family. If you enjoy exploring the biggest questions in the universe, make sure you subscribe and ring that notification bell. And check out our other video on black holes to see what other secrets they might be hiding. Until next time, keep looking up.